All right, take a look at 10.7. 10.7 is going to work with the equation of our circles we've been dealing with. So one of the things you're going to need to know is you will need to know how big your radius is, because that determines how big your circle is. There's really only two things that you need to know about drawing a circle, and that's how big it's going to be, which is determined by your radius, and where you are going to start that circle, which will be determined by the center of your circle. So as a quick reminder, if they give me the center and they give me a point on the circle as they do here, essentially all we are doing to find our radius here, that radius is just our distance between those 2 points. So that distance formula says you subtract your x's, so it's -1 minus 2 squared, plus, and then we're going to do the same thing with our y's, 2 minus 3 squared. -1 minus 2 is -3. I'm going to have to square that. 2 minus 3 is 1, and I'll have to square that. -3 squared is a positive 9. 1 squared is a positive 1. We add them together, we get the square root of 10. So there's the distance between our 2 points. As I was mentioning, when it comes to working with this equation, there are really two things that you need to know. The standard equation of a circle with your center at what they call h comma k, so that's just your point here that we have for our center, and your radius, which they are calling r, is x minus h squared. So all we are doing is taking this h value and plugging it in, plus y minus k. So we're going to take our k value and plug it in. And then we take that equals your radius squared. So we're going to take our radius here. We'll plug that in. So really there's three variables that we are going to plug in. So the way we start these problems is by finding the center and finding the radius first. So if I look at my picture here, my center is at the point 0, 0. And as it turns out, my radius is 2. So my equation says I take parentheses x minus whatever the x value was from your center. In this case, that's 0 squared. Plus y minus whatever the y value from your center was. So in that case, this is 0 also squared. Equals whatever that radius is squared. Once you plug in those pieces, then we just simplify what we can. X minus 0 is just x. Y minus 0 is just y. 2 squared is 4. And that is what our equation will look like. X squared plus y squared equals 4. Right? Same thing in our second one here. But please note, your scale is by 2's. So my center is still at 0, 0. But now my radius is 2, 4, 6 units long. So our equation starts off, it is always x minus that x value from my center, plus y minus the y value from my center, equals my radius squared. Simplifying it down, we get x squared plus y squared equals 36. So there's our equation that we have. So that standard equation of your circle, we use the center and the radius to create that equation. So it is x minus h squared plus the y minus k squared equals your radius squared. So in our problem here in example 2, it says write the standard equation of a circle with 0, -5. I should say with the center of 0, negative 5, and a radius of 3.7. Right, so it is x minus the x value from my center squared plus y minus the y value from my center squared equals our radius squared. X minus 0 is just x. So we have x squared plus, all we can do with the y minus negative 5, y minus a negative becomes plus 5. We are not going to expand that. You're not going to FOIL it out because it will just make this problem uglier and make it look more complicated than it needs to be. Equals, and then we do our 3.7 squared. 13.69. There is our answer. That's all we are doing here. Come up with that equation. Now, they'll also ask us to go the other way. Meaning they may give us the picture and ask us to come up with the equation then. So from this, the two things we always need is the center, which they do give us here. Oops. As negative 1, 2. Now the issue is if you look closely here, that radius, it doesn't make it all the way to that point of 2, 2 there. It stops just short. So we need to figure out what that radius actually is. This is where that opener comes into play. We need the distance between our center and that point on our circle. So we need the distance from negative 1, 2 to 3, 4. So we subtract our x's, negative 1 minus negative 3 squared plus 2 minus 4 squared. Negative 1 minus negative 3 becomes negative 1 plus 3. So we have 2 squared. 2 minus 4 is negative 2 squared. 2 squared is 4. Negative 2 squared is also 4. So we end up with a square root of 8. Now, I actually don't even care to simplify that or reduce that or put it as a decimal. And we're going to show why here in a second. So we have our center, we have our radius. Now we're just plugging in. Our equation says we do x minus the x value from our center, which was negative 1 squared, plus we're going to do y minus the y value from our center, which was 2, equals the radius squared. X minus negative 1 just becomes x plus 1. Plus y minus 2, there's nothing to simplify there. It just stays as y minus 2. Now, the whole reason we left that radical 8 is because when you take a square root of 8 and you square it, these two operations are going to cancel each other out. And it's going to leave me with just 8. So my equation of my circle is x plus 1 squared plus y minus 2 squared equals 8. So the equation of our circle is given to us now. They want us to graph it. Once again, to graph it, we need the center and we need the radius. Now, this for the center, you have to be careful. And a lot of people will look at this and want to say the center is at negative 2, 3. But remember, my equation says x minus h. Well, the x is there. The minus sign's there. All I want is what's there for h. So the h is actually a positive 2. Essentially, you want the opposite sign of what is there because it's x minus h and it's y minus k. So you want the opposite of what is actually there. So we want the opposite of positive 3 then, which would be negative 3. Now remember your radius, this 16 was my r squared. So if I take the square root of both these values, my radius is actually 4. So we start with the center, which is at 2, negative 3. Once again, notice your scales by 2's here. We go 2, negative 3 would be right here. Now, my advice to you on how to draw a circle here, give yourself a couple feeler points. We know our radius is 4. So go right 4, go left 4, go up 4, go down 4. And then you can go ahead and connect your points. And it kind of gives you a feel of where your circle should be. Which brings us to our last problem. It says you bury a time capsule and you use a grid to write the directions for finding it. Use the following measurements to find the burial location. It says the capsule is 11 feet from an oak tree that was at 0, 0. So here's my point 0, 0. Notice your scale is by 4's here. So we want to go 11 feet from the oak tree. So we can go 11 feet to the right, to the left, up, or down. And it could be anywhere on that circle that connects those points. So you can go to Lowe's or Home Depot, rent some type of backhoe, dig that big old trench out until you find it. Or you left yourself other clues. Your next clue here is that the capsule is 8 feet from the flagpole, which was at 0, 8. So here's my flagpole. It could be 8 feet to the right, 8 feet to the left, 8 feet up, or 8 feet down. Or anywhere in between. Now, as of this moment, there are 2 places that this capsule could possibly be. It could be here, it could be here. So yes, you can go to the garage, you can grab a shovel, and you have a 50-50 shot of getting it right. However, they also tell us that that capsule is 4 feet from the mailbox, which was at negative 12, 8. So here's my mailbox. Could be 4 feet to the left, 4 feet up, 4 feet to the right, 4 feet down. Your capsule is located where these 3 circles will intersect, which is right here. The coordinate of negative 8, 8. Right, and here's your homework. Pages 702 to 703, numbers 3 to 25. Please complete the odds only. If you have questions, please make sure you let me know. Other than that, please have a good day.